Okay, this video will be about inverse trig functions from chapter 5.6. Okay, so whenever you're given a problem that looks like this, it's basically saying what angle, for this question, say what angle has a sine of root 3 over 2. So you basically really need to know your unit circle for these. So you can say the arc sine of root 3 over 2, well, that would be pi over 3. Okay, and arc cosine or inverse cosine of negative 1 over root 2, well, that's going to be 3 pi over 4. Now this one gets a little bit more complicated. So you're going to want to take the cosine of both sides. So cosine of cosine x plus 4 equals the cosine of 0. And remember that cosine, that the way that this is written is the same thing as this. Okay, so then these will cancel out because they're inverses. So you'll be left with x plus 4 equals, and then the cosine of 0 is 1. So just subtract that. So then you'll get x equals negative 3. So again, for these problems, you're really going to need to know your unit circle. Alright, so if we're given y equals inverse sine of 5x, and you're asked to find cosine of y, well, you're going to need to draw a triangle to help with this. And it's going to be a right triangle. So if sine is 5x, it's going to be, sine is opposite over hypotenuse. So this will be 5x over 1. And then just, because this is a right triangle, so you can solve for this side. So it's going to be 1 squared minus 5x squared, so 1 minus 25x squared. And then to find cosine y, you just use the triangle and find it. So cosine of y equals 1 over 25x squared over 1. So cosine of y equals 1 minus 25x squared. Now for this one, if y equals the inverse cosecant of 5 over root 3, again, you're going to need to draw a triangle. It's a right triangle. And again, just label it. So 5 and root 3, because it's hypotenuse over opposite. And then again, solve for the side. So this is going to be 25 minus 3, which is root 22. And then the tangent is this opposite over adjacent. So tangent of y equals root 3 over root 22. Okay, now these are the derivatives of inverse trig functions. And so basically the derivative of arc sine u equals u prime over 1 over, or the square root of 1 minus root 2. And d over dx of arctan of u is u prime over 1 plus u squared. D over dx of arcsecant u equals u prime over absolute value of u times the square root of u squared minus 1. And then basically all of the rest of them are just the negatives. So like you only actually have to memorize 3 of them, because the other three, these three with the cos in it, cosecant, cotangent, cosine, those will all be negatives. So you only really have to remember the three of them. So these are really important to memorize and understand them. Okay, so if we're given d over dx of sine of, or d over dx inverse sine of x squared, we're gonna use what the derivatives that we just learned, and that's gonna be so d over dx sine -1 u, that's gonna equal, we just learned it's u prime over 1 minus u squared. So this is, so u is going to equal x squared, so that means u prime is going to equal 2x. So then we can write 2x over 1 minus x squared squared. And then you're going to have to simplify that. So this is going to equal 2x over 1 minus x to the 4th. Alright, now for this one, we learned that d dx tangent 1u equals u prime over 1 plus u squared. So again, u will equal, it's going to be easier to write this as x to the 1/2 rather than root x. It'll just make the math a little bit easier. And then u prime is going to equal 1 over 2 root x. So then this is going to equal 1 over 2 root x all over 1 plus x to the 1/2 squared, which is going to equal 1 over 2 root x times 1 plus x. Just basic algebra. And that's the end of this video. Thanks for watching.